Hi again everyone, welcome back to ptet.chemistry channel. So this is the start of these multiple choice tutorials on topical MCQ. This is on group 2 chemistry in particular. So throughout these MCQ tutorials, you'll see me going through concepts that might be beyond whatever is asked in the question. So this will serve as an overall recap as well as revision of your A-level concept if you ever need it. But it does not substitute what you're supposed to have read from textbook and learned in school as well, yeah? Okay. So we know that group 2 nitrate, in general, you should be able to write the balance equation where group 2 will form M2 plus cations when they form the nitrates. Each nitrate has an NO3 minus. So the LCM of 2 and 1 means that you need 2 of the minus 1 in order to get a compound which has no charge. When you decompose it, you will form a nitrate. You form an oxide and you will form NO2 and it will give you oxygen. And you have to balance the equation. Since you have 2 nitrate, you get 2 NO2. Now your M is balanced. Your 2 nitrogen are balanced. You have 6 oxygen. You have 1 oxygen, 4 oxygen. Therefore, you need just 1 oxygen there. To get 1 oxygen atom, you do half times the molecular oxygen. You will get 1 oxygen atom. This is a gas. This is a brown gas. The O2 is a colorless gas. These are white solid in general because all the group 2 oxides are not transition metal oxides, so they are not colored. Alright. So the brown gas is very easy to notice. If you do this in the lab, if you hit a white solid, you get a brown gas. You should test for this colorless gas, which you can't see, but you should test for it knowing your group 2 chemistry very well. Alright. So all I've done is I've used half here. So if you see all of these, there's no half in the equation. That's because you can multiply the whole thing by 2. There's no number in front because there's 1. You can multiply by 2 and you get 2. You get 4 and you get 1. It's perfectly fine as the way it is. I always prefer this, but simply because here you know you can multiply the whole equation by 2 or by 3, it will still give you a balanced equation. Alright? So next question seems very popular over the years. Yeah, if you see like there's probably a reason why it's popular. It's not because like a lot of students always get them correct. It's probably because a lot of students always get them wrong. That's why they thought it's very nice to ask it again and again. Okay, but you gotta understand why magnesium hydroxide dissolve in aqueous ammonium chloride but not in aqueous sodium chloride. So you know sodium chloride just dissolve in water to give you Na plus and Cl minus. We get no hydrolysis of the NaCl in solution. That's why it stays pH 7. With the case of MgCl2, you get partial hydrolysis. You get pH 6.5 for the magnesium chloride. Obviously from aluminium chloride onwards to silicon chloride to phosphorus chloride, all you get is hydrolysis and you get acidic solution. So we know magnesium hydroxide is not very soluble in water, so it's not very alkaline at all. In fact, the solubility of group 2 hydroxide increases down group 2. For this magnesium hydroxide, it's not very soluble in water. That's why the pH of it in solution is a weak base, despite you thinking it has 2 hydroxide ions per magnesium 2 plus. Because it's not very soluble in water, in an equilibrium, you don't get a lot of it. You get only partial dissociation into OH minus. You get a weak base, alright? But what does ammonium chloride do? Well, ammonium chloride can also dissociate in water to give you NH3 and HCl. So that can happen. Guess what will the HCl do? What will the HCl do? If you have this mixed in with this, the HCl neutralizes the OH minus. That means you get H plus plus OH minus give you H2O. I mean, you have seen this probably 1,000 times because you have done quite a lot of acid-base neutralization reaction. This means that the HCl from here can remove that. So what will your OH minus do? That will happen, right? Because you remove the OH minus. What will your equilibrium do? You have a reversible reaction. This is in Lee-Chatelier principle under chemical equilibrium. Your equilibrium will try to increase your concentration OH minus. It will shift to the right. It will favor forward reaction. What is this forward reaction? guess what? This is the solubilizing the magnesium hydroxide. Therefore, more MgOH2 will dissolve, because as you favor the equilibrium to the right, you are making more of this to dissociate into this and this because of the equilibrium conditions. Le Chatelier principle, yeah? It's not an A-level concept, it's an O-level concept, alright? So it's got to do with this NH4 plus can act as an acid, because the NH4 plus can dissociate into NH3 and HCl. Then the acid can neutralize the OH minus. Then all of this can happen. Alright, so I hope that makes sense. They could very easily ask you this in a paper 2 kind of question involving Le Chatelier principle. More importantly, they love to ask ionic equilibrium because it involves the ions. They love to ask this in A2 chemistry involving calculations, okay, to do with calculations of pH value. Alright, okay, based on the concentration of OH minus and H plus, that can come out in A2 chemistry as well. Whew, next question is also quite popular. So, what can be precipitated when you add in calcium hydroxide? So, as you know, calcium hydroxide is more soluble than magnesium hydroxide because the solubility of group 2 hydroxide increases down group 2, but still it's not the most soluble thing in the world. If you think about what will be precipitated, I can tell you the nitrate is not, because you would have known that nitrates are very soluble in water. That's why you have a problem when you use nitrate fertilizer. The nitrate fertilizer get washed easily by rainwater, right, into your river and cause eutrophication, and you don't want that. Plus, the nitrates are all soluble in water. That's your solubility rule of salts in O level. You're left between calcium chloride and calcium carbonate. The calcium carbonate is a chalky kind of thing. It's present in limestone as well as marble. It's the one that is very insoluble. All the group 2 carbonates are insoluble in water, okay? So what happened with that is that when you have test for CO2, you bubble it through lime water. Lime water is actually saturated calcium hydroxide. This is the base. This is the acidic oxide. You're going to get neutralization. That means you're going to get a salt. The salt of carbon dioxide is CO3 2 minus, because there is carbon plus 4 oxidation state. Guess what it was before? CO2 is also carbon plus 4, because this is an acid-base neutralization. A neutralization is not a redox. So that's why you still get neutralization. And because you have hydrogen there, you have got to produce some water as well. And your equation are balanced out. This is the chalky, milky precipitate that you see when carbon dioxide is present and you bubble it through lime water. Yeah, lime water is saturated solution of this. It will give you this white precipitate there. Okay, so straightforward then. So next question, thermal decomposition. So very similar to what I said in the first question. So once you have written enough of this balance equation, you can write it balanced straight away, just like that. And there's a reason why you should practice writing this, because you gotta know when to balance it, yeah, how to balance it. You always need a balance for your calculations. Oxide, NO2 and O2. Alright, there's the brown gas, there's the colorless gas. All the group 2 oxides are white in color because, well, you will learn more about why transition metals are colored in A2 chemistry, but as you know, if they are not transition metal oxides, then they tend to be not colored at all. So now you react the metals with oxygen and you get the oxide, because M2 plus and O2 minus, the most alkaline solution. When you think about it, group 2 oxide, MO, plus H2O liquid will give you MOH2. That will be the equation balanced straight away, aqueous. But this question is actually asking you the solubility of the group 2 hydroxide down the group. In AS, you are only expected to state the trend. The trend is that it becomes more soluble down group 2, and that will give you more OH minus because it fully dissociates. That's why very strong base down the group 2 hydroxide, But things like magnesium hydroxide, very insoluble, not very soluble in water, partially dissociate in water to give you weak base. So the most alkaline solution has to come from the one with the biggest ionic radius. That's the one furthest down the group 2. Okay, so this is the end of this short tutorial. Make sure you subscribe to the channel if you haven't. If you enjoy these videos, please do like the videos and leave some comments if you've got any about the videos I made, and share them widely with your colleagues or your friends so that more people benefit from this. Alright, thank you for watching.